Hello, my name is Antoni Ivanov. I am from Bulgaria, and I've been leading for the past years uh, Versatile Data Kit. It's a project that was built internally in VMware. It was open source last year. It's a ETL framework and also providing some facilities to ingest, transform data, and also platform, which provides the ability to orchestrate and manage and operate data applications, any application, really. But today I'm gonna not talk much about versatile data kit. Its focus is about more practical Kimball data patterns, and we'll go over very quickly the data science and data engineering process, and what is dimensional modeling, and then deconstruct the Kimball best practices into three things: architecture, process, and techniques, and explain them. And then I'll point you to some examples, resources which you can practice with versatile data kit. Right. Okay. Cool. So, before we continue, let's see what the typical data engineering or data science flow is. Usually we start with well, being asked some kind of interesting question, trying to understand what the problem is, uh, uh, trying to see how we can solve the problem. Ultimately, once we have some better idea about the domain, the first thing we need to do is try to find the data, discover where the data is. The things are improving quite a bit in this direction with data catalogs and lineage. It's still a bit challenging, but let's say that once we have some good idea where to get the data, we need to ingest it and possibly and prepare it, do feature engineering if needed, do some kind of cleaning, data preparations. I'm gonna call this data modeling, and then we do actual training or with the data science world and communicate to realize the results. In the data engineering world, we'll be embedding this data in application or creating reports. There's still a lot of challenge in this kind of exploration of data, cleaning, preparing, modeling that needs to be solved. And dimensional modeling is one design patterns which provide us a better and clearer way to be able to do this kind of data modeling for relational data. So data modeling, again, is the process of really defining how our data is structured to meet our business requirements. We get data from different source systems. Usually this kind of data can be that if you use something like segment terabyte, for example, you find 1,000 tables for each different events, or you may find them different formats of the data. And we'd like to make sure that we have a certain data model which is guaranteed with quality, which has certain promises to its users. Ultimately, the data model, which ends up is the one that gonna be served as a product to users. Those users could be ML engineers, could be data analysts, could be anyone. As any product, this product needs to be tested, it needs to be monitored that there are no regressions, it needs to be tracked for customer satisfaction, and so on. Ultimately, dimensional model and the part where ML modeling goes in is when we have a data model, often this data model is used in pod to create a ML model. It's a common process, I think, in data engineering, ML engineering, where the model is used as a part of training, generally from features extracted from the data to predict or classify different events. So we're thinking about the data model is basically the prepared data that's gonna serve for the use cases. Well, ML model is the model object that's being produced by the training, which allow, allows different use cases like usually prediction and or generation. So dimensional modeling is a specific type of data modeling uh, that uses particularly wait, that uses particularly dimension and fact tables to represent the data in a database. Right. We usually call it data warehouse. What are facts? Probably some of you know, but facts are generally measurement or metrics about a business process. So, for example, when I trying to modeling, and I use this example again, I think it about, let's say I think it as a sentence. Let's say that we model business process, which is Tom sold 3 apples on in Washington D.C. On February 3rd. The usually the fact table is something that is very close around the verb of the sentence. It represents and the metrics around the verb. It represents this kind of business process and event that's happening. We can track fact tables in different grade, which we'll speak in a little bit. So the sales, I sold 3 apples. I sold is the fact table. So we track the fact in the sales fact table. The dimension table is a companion table to the fact table that contains descriptive attributes. It usually answers all the other questions: who, what, where, when, why, how, all the W's with the event. So who sold the apples? I did. Oh, Tom. When did he sell them? On February 2nd. Where did he sell them? In Washington, D.C., and so on. That's a very simple way, and which is one of the power of this dimensional modeling. It's an extremely simple way to determine the type of tables you want, which is one that anybody can do. It doesn't require studying 5 years in university to be able to do it. You just can imagine that you can speak English or any language and you can imagine the sentence, then you should be able to approximately visualize which things are the fact tables, which are the dimension, and you have star schema design extremely easy. That's one of the very power of dimensional modeling. And so simplicity, as I mentioned, is what I'm talking about. The dimensional models in this way are easier to understand and much more user-friendly, as they present a formatting that's very intuitive, I hope. Ultimately, this simplified structure often leads to a bit improved query performance. Part of this is that unless you go really dimensional model tends to be less normalized, which means that you can afford to have a bit of redundant data in the same table to reduce the number of joins. which tends to leads to better query performance in analytical systems, which things like Snowflake or Power, Trin or Redshift. Since dimensional models are designed to present a consistent view of the data across the business, this makes them really reusable for all kinds of tasks. And because the data typically is organized in business categories, it can be easier to interpret them and, for example, to create features from dimensional modeling for any task. Well, what is actually Kimball is Ralph Kimball introduced the data warehouse business and the whole BI to dimensional modeling. There are other approaches to data modeling that are commonly mentioned, like in-moon data modeling, and later there's also talk about data modeling in the 2000s, which you can also check. But today we're going to focus on Kimball data modeling, and we're going to split it into three different things. Those three different things can be used completely independently if you want. You can use them together, you can use one, two, or three of them. One is the Kimball architecture. The second is the Kimball design process. And the third thing is the Kimball technique or design pattern. I don't design patterns because the Kimball techniques are very similar to software engineering design pattern, but for modeling. So I'm gonna very quickly mention about the Kimball architecture. You can read a lot more in the Kimball group data site, which is linked above in the short link, bit.ly Kimball architecture. So the Kimball architecture separates the data in process into backroom and a front room. You can see. So this is I've worked actually in a restaurant a decade ago. So I've worked both in the kitchen, making breakfast, and as a waiter. So for example, I remember one story where I was working in the kitchen. Making eggs over easy, which means you need to flip the egg and make sure it's not broken. And then you put hash browns and bacon. I remember, for example, sometimes you couldn't flip the egg perfectly and it breaks. So once when I was having really unlucky trip and broke a few, I tried to push one to the customer. Fortunately, the waiter immediately noticed it and stopped me and asked us to remake it because the customer has certain expectations about how their meal looks like. There also, I remember the sous chef telling me that I need to put like 5 bacons exactly, not 6 or 4. Exact amount of hash browns, exactly 2 eggs, right? So this kind of analogy is something that the Kimball architecture proposes. So in the back room is where basically all is a bit more chaotic. While the backroom must be really efficient, so that people do not try to make things harder for themselves, and the quality anything must be clean, and the ingredients must be of high integrity. It's still generally off limits for patents, as things like you can break an egg can happen, and you want to make sure that things are working without a problem and don't give a wrong impression. And then the front room is where in the restaurant that things are clean. Things that come out of the back room have quality checks in my case, this was the waiter making quality checks on me. Have certain guarantees about what's being output. And this is where the front room is. There, things like quality and presentation, easy access are very important. This is what basically Kimball architecture proposes, that when building, you make sure that you separate those. In some ways, this is very similar to, in my mind, to the concept that is coming from data mesh, which is treating data as a product. In your backroom or in the backend, you can do whatever you want, as long as the business model or the data model they output is one that satisfies customer needs, it's easy to access, it's documented, it's a good quality. This kind of data model is pretty important. I do recommend checking out treating data as a product and data mesh more, which I think complements with this. The second thing that Kimball proposes is so-called Kimball dimensional design process. Those are 4 simple steps where if you answer those 4 questions, you can start iteratively building your data warehouse and data model. One of the good things about the whole design process is you allow this kind of iterative way of building up. You don't have to try to build everything from scratch. So the first step is defining the business process, of course. Before you could go ahead, you should understand the business process that the design support. The questions the business user have. So, for example, maybe we wanna make sure that we track the balance of if we're in a bank, the balance of our users, and be able to output some kind of report at the end of the month. Maybe we wanna make sure that we track every time somebody, or if we're in an airplane, we wanna track every user who boards the plane. This kind of things is the first thing we identify. It comes from identifying what is the interesting question that you want to answer, the problem that you want to solve. It certainly requires consulting with business users, examining the source data in order to be able to determine what actually you can do also. The second part is identifying the grain. As part of identifying the grain means for this business process, at what granularity you want to track the events. There are different types of grains. For example, for making a report at the end of the month, having a month grain where you track simply the balance sheet at the end of the month is something that you want to do. And while for much more frequent, when you want to track every single event happening as it happens, like boarding a plane, the event is the actual event that you're interested in. For example, maybe you're interested in the boarding pass scan at the gate of a passenger. That's the actual grain. The third the step is to question answer. The step is identifying the dimensions. Now once you know what your business process is, and then the best way I recommend is again to be able to describe the business process in a single sentence. Like we need to report at the end of the month for customer in bank X and so on. We need to understand each user boarding a plane, at which plane, at what airport, and so on. By describing it as a sentence, I customer X boards a plane at 3 o'clock on airline Ryanair, Washington DC to New York. I don't think Ryanair flies in New York, but still, you can visualize in your mind and helps you go through this process easier. Since we have sort of defined our business process, including the customer boarding the plane, now we can provide better context for it, like answer the questions what, how, where, when, uh, which will give us our dimensions: date, passenger, flight, airline. And finally, the fourth step is identifying the facts, where you identify what kind of exactly fact tables you need. This goes again from once you have the grain. So, for example, if it's the grain is month, most likely you need some kind of snapshot table, and the grain is every single event. You need transactional table, fact table, and your business process is boarding a plane, and your fact table will be a passenger boarding the plane. Your business process originate report in the month. Maybe your fact table will not come by a snapshot. And so this is basically the Kimball design process. It's something that you can employ at very different granularity. You can literally employ it for 1 hour when you're designing, when you're downloading some data uh, from Salesforce or GitHub or anywhere, and try to create some kind of module for your report or for your training data. Just going through this process in your head when you're doing it would help you generate the report, the data, the model, the data easier. You can do it as a team, much more structured way, and you can do it even as a group. There are different levels because this kind of dimensions are process pretty simple. You can put even small thought about it, still it would help. You can put a lot of more thought about it in the research. It's entirely up to the needs that you have and what stage you are currently. For POCs, you probably do it quicker. For something that you want to be much more mature, you probably want to do more research. But the simplicity again of the process makes it possible to be used widely. So we went over the Kimball architecture, and the second thing, Kimball measure design process. Those things are independent. You can use one thing and use independently. And the third thing will go over some of the modeling techniques or design patterns that are proposed by Kimball. So basically, design patterns are a way, sort of like a predefined techniques that you can use to model data in certain ways. For example, if you want to model your data, like in the case we had for boarding an event, use transaction fact table, which you explained in a bit more. If you want to model the data once a month, you probably use periodic snapshot fact table. If you want to model something that changes state, use the cumulative snapshot fact table. There are different types of modeling for dimension tables as well, like so change dimension type. And quickly explaining, transaction fact tables hold the data for individual business transactions in event, with each row in the table representing a single transaction or event. I think they might be some of the most common type of fact tables because they provide the most detailed information, but also those tables tend to be the biggest one. The second type of fact table is periodic snapshot. Here the grain is more aggregated. They provide summary or snapshot of the data at regular predefined intervals, daily, weekly, monthly. As in our example for monthly snapshot of the balance sheet. These tables can contain the state of the facts as they exist at a particular point in time. They also can often contain some kind of aggregates for at the end of the month, for example. The key tend to be some kind of also entity. You can have the details about each customer every month populated in it. There was broadly used Kimball fact table is accumulating snapshot. Accumulated snapshot is designed to handle the specific scenario where a business process includes a series of steps that must be completed before the event is considered finished. And the classical example, as shown in the slide, is the sale event. First, the customer orders a thing. This goes in the backlog. Then it to be manufactured and finally released and then shipped to the customer. And of course, get invoiced. This kind of things that go over multiple step process are designed to accumulate snapshot fact table where each row represents the order and it gets updated over time as it progresses. So you can do things like querying, give me all orders that occur at the shipment stage or orders that ship before this date and so on and so on. Okay, that's basically what a quick mention about Versatile Data Kit. As I said, Versatile Data Kit does provide some facilities to transform, ingest, and export data jobs. And I'm gonna leave you with the exercise that you can try at home if you want to. If you go to this URL, you'll need approximately between half an hour and an hour. But you can try out and see if you can create your own dimensional modeling with Versatile Data Kit. And yeah, and thank you for listening to me. I hope you find it useful and interesting. And feel free to contact me using some of those channels. Thanks.